Okay. Yeah, let's go to problem number 6. Okay. Here it is. Okay. So write the manual part program for the given diagram. Okay. Right. So the given diagram is here. Copy down this diagram. Here the vertical distances are 50, 50 and 50. The horizontal distances are 75 and then the next one is 125. Over. Finish copying it down. Hello. Okay, so we'll go to okay, so here for this diagram we have taken it as this is point number 1, okay, and here point number 2, 3, 4, 5, 6. Okay, so these 6 points, and then for the drilling to be done, we need the centers for this. So 7, 8, and 9. Okay, right. Plus from this, we are going to leave. We are going to place it from all the 4 sides at a distance of 25 mm in X as well as in Y direction. Right, from all the 4 sides. Okay. So for this, uh, uh, the question will not be given like this, that you have to use scan cycle, then you use G81, G76, all this will not be given. Okay, you will be only given as write the manual part programming for the given figure. Okay, and for whatever it will be indicated in the diagram or it will be mentioned in the question. That is it has to be drilled to so much of depth, having this diameter, and it has to be reamed. So we cycle and all in the last class. And then the other thing is that it has to be only drilled, and the other thing is that it has to be you have to use boring also, whose diameter is so much for so much depth. Okay, these details only will be given either in the diagram or it will be put up in the question. Okay, in any one of the places it will be there. So based on that, we'll have to select the suitable CNC codes and use it in the program. Okay, right. So coming to this point number 1. Okay, that is over here. It is going to be at a distance of from x-axis. Yeah, from x-axis, it is going to be placed at a distance of 25, comma 75. Y is going to be 75 because this distance is already 50. Plus from there to the edge of the plate, it is going to be another 25 mm, so 75. Okay, then the next point over here, x value again 25, y value it was already 75 plus another 50, so 125. Okay, then third point, over here. So third point is going to be at a distance of uh, third point, no? Yeah, here, coordinate number 3. So x value, this is already 75, horizontally measuring from the origin, and plus 25, so 100. Okay, y value, okay, 25 plus 150, so 175. Then from there, it's going to be a straight horizontal line for another 125 mm, right? So x value is going to be 100 plus 125, so it's going to be 225. Okay, that is going to be point number 4. Okay, and from there onwards, it's going to be a radius. Okay, sorry, and for point number 4, the y value will be 150 plus 25, 175. Okay, and then from there onwards, it's going to be an arc in clockwise direction for a radius of 75. Okay, and point number 5 will have a coordinate of x value will be 25 plus 75, 100 plus 125. Okay, so totally 225. Y value, it's going to be only 25 mm. Then point number 6, okay, plus 75, that is 100 for x, and for y it is going to be only 25. So with this, all the borders has been covered. Next is the coordinates for the center of the hole. Okay, so for point number 7, okay, it is going to be at the distance of 225 x value. Y value is that it's from the edge of the plate is just 25. Then from here, okay, if you look at this, this is 20, 75, this is 50. So this distance is going to be another 25. Okay, so 25 plus 25, 50 over here, point number 7. Then point number 8, here it is going to be at the center, half of the distance, half of the width. Okay, so even if you take it like that, it is going to be 50 plus 25, 75. Okay, plus another 25. Okay, that is going to be the y value 100. X value will be is going to be here. So it is 25 plus 75 plus 125. So totally 225 plus this radius, right? This radius is 50, right? 225 plus 50, 275. And then point number 9, x value will be same as point number 7 only. Okay, so it's going to be 225. Okay, y value will be, here it is 25 plus 25, 50 plus it's going to be, this is 50 plus this is 50. So totally 100 plus this here that we already had in the first step. So totally 150, right? Let's make a note of these coordinates. Right? Okay. Right. So here the thing is that for this particular thing, it is actually not there in the question. This diagram is actually given to do drilling and then perform counter boring operation. To do drilling and counter boring operation. Right? Okay. So I'll just throw this for drilling cycle for boring. It's going to be G76. Drilling cycle, as we know, it's going to be G81. Okay. Yes, in finished boring, what is there? The G76 is the code. Okay, so boring, as we all know, we want to enlarge all the hole that is present if we don't have the required diameter of drill bit. Okay, right? So for this G76, X, Y, and Z values, coordinate values. Okay, then R is going to be the initial safe position. That is, after the boring operation, where should it be? Okay, that is, we want it to be always at least 5 mm above the surface of the workpiece. Okay, then comes the uh, shift amount at the bottom of the hole, that is represented by Q. Okay, dwell time, if at all if it is required, we can give, otherwise it is not required. Thus, along with the feed rate, at what rate should the tool be moving? Okay, this is the syntax for finished boring operation. Yeah, right. So shift amount at the bottom of the hole is nothing but what is the incremental distance by which the boring tool should move vertically in the downward direction. Okay. Right. Yeah. So we'll go to the program. The first is the percentage symbol, then capital O followed by 4 digits. Yeah. Then we'll go with G9N01, G21, G40, G94 and G90. Okay, that is to represent the absolute coordinate system, SI units, and so on. Okay. The next line, okay, G28, X0, Y0, Z0. Okay. Then next line, M0, N10, M06, T0101. Then the next line, G43, tool length compensation. Whatever is the compensation value to be stored in registry H01. Then next line, M03, spindle start, speed at 1500 and coolant on M08. All right. So next, what we have here is 0, X0, Y0, Z10. Here, this is not required. We can have it at have this value. You can get it directly over here. You know, always. So you can directly get the tool at X25, Y75, Z10. So the tool is above the workpiece surface. Okay, right? That is, we are trying to get the tool over here in this particular place directly from its home position. Right. So next is one second. Okay. Right. So from there, we can give it as one second. Okay, this is not required. F100 we can give it over here. Not at all required. Right. So next we can directly go in such that the tool will go in by distance of 10 mm. So G01 Z minus 10. Okay, and F feed rate at 100. Okay, mm per minute. Okay, then G01 x value is going to be same as x25 only for point number 2. Okay, so only y coordinate will change. So y125. Okay, and we are asking the tool to move in the same speed. Okay, f100. Okay, next x next point, that is point number 3. So y is going to be 120. Sorry, no. So next is G01 x100 y70 175. Look at point number 3. Okay, right. Then comes from there onwards again a straight line moving horizontally towards the right hand side. So x value changes from 100 to 225. Y value is the same. Okay. Then G02, from there it's going to be a arc from point number 4. Okay, for a radius of 75. Okay, so x 225, y 25, radius 75. Reduce the speed when it is going for any circular motion. So f70. Okay, then G01, from there onwards, from point number 5 to 6, it's going to be a straight line, x100. And then reach to point number 1 itself. We have to end it from where we started, going in for one complete rotation. So from here, now we are going to travel to point number 1 to complete the cycle. So G01, X25, Y75 itself. Then get the tool outside the surface of the workpiece. G01, X5 or 10 you can give. Then spindle stop, M05, coolant off, M09, right? And then G28, X0, Y0, and then Z should not be okay. Supposed to send it to home position. Okay. Actually here it's better that you're okay. Z5. All right, let it be there. Okay, then next line M06 tool change. Tool number 2 for counter boring operation. Sorry. Okay, yeah. Tool number 2 for drilling operation, G43H02, then M03 spindle start, spindle speed, rotation speed 1000 RPM, coolant on M08. Then next line G00. So point number 7, we'll give the coordinates of that. Yeah, X225, Y50, Z5, R0. If you don't give the 0 in this particular software, it will give an error. So just keep that always. And then G99, cancel the cycle. Okay. One second, not to cancel the cycle, it is to return back to its safe height. Okay, safe position in can cycle. Yeah, then G81 for drilling. Okay, until for the required depth, to do the drilling for the required depth. So it's already at the required center, only the depth is the Z value should change. So Z minus 40 or 30 you can give. Okay, and R5, that is G99 we have given. It has to return back to its safe height. So R should be 5. That means 5 mm from the surface of the workpiece. Then it should drill a hole at a speed of 35. Yeah. F35 feed rate. Next, it has to go to the next position, that is point number 8. Okay, whose value is one second. Yeah, X275, Y100. Okay, and then the third point, X225, 137.5. No, not at all. It is 150. It is 150. Okay. Right. Okay, next. G28, sorry, G80, that is to cancel the cycle. Okay, G80, cancel the drilling cycle. Then M09, coolant off, spindle stop. Okay, then here it is repeated, not required. Okay, then G28, X0, Y0, Z5. Then go to home position, M06, T03, 03. Position G43, head 03. Spindle start. And it's going to be boring operation. So let the spindle speed be lower. Okay, so S500, coolant on, M08. Then G00, X25, Y50. That is the coordinate value for point number 7. Okay, and at a height of Z is equal to 5. Next, G99. So it has, after doing the boring operation, it has to return to its safe height. Okay, safe position. G99, G76, which is the boring cycle. Then R5. Okay, safe height. Okay, Q is 0. Did we see for Q? Yes, Q is the shift at the bottom of the hole. Okay, then Z up to 35 minus 35. Okay, it's going to be 75. Then, so the next point for boring is X275, Y100. Then the third point is X225, Y150. Then next one is G80, end the can cycle, stop the cool the spindle, return to home position G28, X0, Y0, Z5. Okay, and then M30. Okay, right. So this is the program. Okay, yes, copy down this program. Copy down the program. Yes, have you all completed it? Have you all copied the program?
No, sir.
Okay. Power? Finish copying it. Over, guys. Finish copying it.
Yes, sir.
Hello.
Yes, sir.
Yes. Okay. So we'll see the simulation. Copy the file from the notepad. Okay. Yes. So make sure that you leave 25 mm from all the four sides. Okay. X, Y, and Z. Uh, X and Y coordinates. Blank thickness. You can take it as 50 mm. Okay. So select the machine and connect for CNC milling. Go to tools. Till now we have not discussed about the what is the diameter of the tool to be used. Okay, it will be given in the question. Okay. So here for end milling they will not give. We can choose it for usually 5 mm or something like that. Okay. And then for drilling, they would have told that you have to do drilling and do counter boring. So drilling after counter boring, it has to be for 25 mm. Okay, that should be the diameter. So drilling, twist drill diameter should be less than that. Okay, less than 25 mm. So we'll select 24.75 or 24.5 mm diameter of drill bit. And then for counter boring operation, we'll select 25 mm counter bore tool. So first tool, which is the end mill. Okay, end mill tool. Ensure that the tool library is in mm. End mill tool for 5 mm. Okay, diameter. Flute length, increase it. Length of the holder, length from holder face to 100. Flute length, make it 40 or 50 mm. Better make it even 50 mm, not an issue. Yeah. Then go for point number 2. Tool number 2. Drill, twist drill. In that, go to 24.75 or 25, less than the required counter bore diameter. So here we have 24.25, 24.5, 24.75, then we have 25. Okay, so we can select 24.5 or 24.75. Okay, and ensure that even this length from tool holder face is longer. Okay, and flute length is also going to be higher. Okay. The next number 3. Okay, which is going to be counter bore. Go to bore, then in that bore finish. Okay, this is meant for finishing the hole. Okay, so 25 mm. Okay, diameter tool. Select it. So here you have. Okay, and of course here also length from holder face and length should be longer enough so that the shoulder does not hit the surface of the workpiece. Check for any errors. Go for simulation. Here we have, that's the end milling tool. Yes, this is the drilling, the 3 holes. Then counter bore. Here you can see a different type of tool that has appeared. So yes, you started at point number 1, ending and starting at the same point, end milling, then change of tool, then drill tool of 24.7 diameter. Okay. Next, counter boring operations. Now the tool is returning back to its home position. Right? Okay. Actually, this should not happen actually, because it will damage the base plate. Okay. Uh, right. Right. Okay. Yes. So please update your records and update it in the classroom. Okay. And yes, and say attendance. Uh, yes, Niharika.
Yes, sir.
Okay,
Yes,
Nihar.
sir.
Yes, sir.
Nikhil R. Nikhil R. Not there. Okay, Nilesh.
Present, sir.
Okay. Nirab.
Yes, sir.
Prajwal Patel.
Present, sir.
Okay, Prajwal S. Bhatt.
Present, sir.
Okay. Prince.
Present, sir.
Okay. Rishabh Pandey.
Present, sir.
Okay. Rohan K. Rohan K. Not there. Okay. Then Roshan Yadav.
Present, sir.
Okay. Suman Sagar. Suman Sagar. Not there today. Okay. Sagar GB. He's also not there. Sanjay Raghav.
Present, sir.
Okay. Sharanaya. Not there. Sagar Dutt Mathur. Even he's not there. Okay. Sheikh Manan.
Present, sir.
Okay. Shobit. Shobit is not there. Siddharth B. Shankar.
Present, sir.
Okay. Siddharth Sridhar. Not there. And Subramanya.
Present, sir.
Okay. Sumuk VR. Not there. Tirmana Shetty Rohan.
Present, sir.
Okay. Yes. Okay. So write your records. Okay. Diagram as usual onto the left side of your page. Table, coordinates table, tools used, another table, and the program onto the ruled side of the sheet and update it in the Google Classroom. Okay, in the respective assignments. Okay.